All right, so I went and slept on this, and I woke up this morning and uh, had some ideas, and I tried to get them to work, and they didn't quite work either. So then I went to work, spent the day at work, thought about it some more, had a few more ideas, came home, and banged them out, and they did work. So let me let me just talk you through them really quickly. So if you remember yesterday when I was trying to do it, um, I was doing all this pathfinding stuff. And it was very slow and very inefficient. And what I realized was that uh, at any point in time, I wanted to go from one key to the next key. And so I didn't need to worry about finding those paths every time. Instead, what I could do is pre-compute all the paths from one key, the shortest paths from one key to another, um, and then use those pre-computed ones. And in addition, um, basically, there wasn't anything tricky where like there were multiple ways to get places. So if I just kept track of um, the shortest path from say key E to key F took 10 steps, and by the way, here are the doors you have to go through to get to it. If I knew all those, then that's enough for me to put together a solution. Um, and then the trick was how to do that. And so here's what I did. So I think this part I actually had yesterday, which is my grid, which was I had walls, which is just set of positions. Like from X, Y is a named tuple. I have keys, which says at this position, here's key A, here's key B. I have some doors, and then I have a start, which is another position again, and just some helper function to take in the raw string and parse it into one of those grids. Okay, and so what I did is I started off, and this is very computer sciencey stuff. Is I did this one source shortest path, where I have the grid and I have the start, and the start is the location of a key. And all I'm going to do is I'm going to basically kind of flood fill the maze, and let's go here and um, so the idea is like I start here, and I'm just going to flood fill the maze and say, you know what? It takes me 1, 2, 3 steps to go to B, and I don't have to go through any um, doors. It takes me 1, 2, 3 steps to go to F. I don't have to go through any doors. It takes me 1, 2, 3, 4, 5, 6, 7, 8 steps to go to O, but I have to get through door D to get there. And so I'm just keeping track of all those things. And so the one source shortest path is basically um, building up these results by doing again kind of a breadth first search, um, and the results map a key like A to a pair. Here's how far it was. Here's the doors I had to pass through to get there. And this is only starting at one point. So you could say, starting at, here's them. And then I also want to do the same thing and say, starting at P, where can I get to? I say, well, in 1, 2, 3, 4, 5 steps, I can get to E, but I have to pass through H, and so on and so forth. So now what I know is, so um, then I took this and created another function, all source shortest path, which basically just runs this function, any number of times. And at the end of that, I basically know for any pair of keys, how many steps is it to get from one to the other, and which doors do I have to pass through. So if I say, if I want to get from K to J, that would take this many steps, and I have to go through doors E and A. So I pre-compute all those things, and it's relatively cheap because it's basically for each starting point, I basically have to walk every square of the maze. So it's number of squares in the maze times number of keys, which is not a lot. So I do that, and now I have these things, and now that's as far as I got this morning. But I couldn't still quite get the shortest path part to work, and so I had to be a little bit clever. And I said, first start off by computing the all source shortest path. And then I'm going to keep track of what I call signatures. And this is to avoid duplicating work. So, if you're doing some sort of maze traversal, you might want to keep track of what are the positions I've been to. But here, I don't just want to keep track of the positions I've been. So, one, we're only going to move to locations where keys are. So we don't have to worry about positions. We have to worry about a location where keys are. But we also have to worry about and what keys do I have when I get there, right? So a position for this purpose is basically saying I'm at key A and I've already collected keys B, C, and F or whatever. And so I have this little signature function that says, given some location and some previous keys that I've already collected, I just make a string where it's the current location colon and then the previous keys just sorted so that if I collected them in a different order, like that, I don't want a different signature. It's just which ones I collected, not what order I collected them in. Okay, and so I maintain this priority queue. Um, and so sorry, I keep a set of here's all the signatures I've seen so that if I find another way to get to basically an identical signature, which means identical location, identical keys collected, I don't need to consider it because I've already seen that. And because I'm doing this in a priority QA, the first time I see it will definitely be the shortest way to get there. So if there's a longer way to get to the same result, I don't care about it. It's the same result and it's more steps. And so again, I start this priority queue with 0 and at, which is where I am, and then the keys that I have. And I just start popping things off the priority queue, number of steps, what key am I at, and what keys do I have. I compute the signature. If I've already seen that signature, I continue. Otherwise, I add it to the signature so that I won't repeat this one again. And then what I say is, if this thing that I just popped off has every key, because this is a priority queue, it was the shortest way to get every key. So, so I just return that number of steps, and that's the right answer. Otherwise, I have some key where I'm at, right? So, maybe this thing I put on the priority queue, I'm at key C. Okay, so now I say find the shortest path to every other key starting at C. And you remember, this says not only how many steps is it, but what doors do I need? So, I just iterate over all those. And I say, one, if that's a key that I already have, keep going. So like, if I'm at key C and it says here's the shortest path to key F, but I already have key F, then I don't care about it because it's not there anymore. And then also, if there's a door I have to pass through that I don't have, so if the shortest path to key D passes through door F and I don't have key F, then I can't go through it, so I skip that one as well. Otherwise, I create a new set of keys where I add this key to the keys I have, and I just add it to the queue with the new number of steps and the new location I'm at and the new keys I have. And so I just run the queue that way, and eventually I get to all the things, and it runs and it works. And so I got the answer that way. So then there's a part 2 where they basically say, instead of having it be one map, where there's this starting guy and like empty squares around him, we're going to change it so that we're going to split the maze into 4 different mazes that has 4 different people in them. And when one of these 4 guys gets a key, that unlocks that door for the other guys too. Okay. And so the goal is still to collect all the keys in the fewest steps, but now at each step, we move each of these guys independently. And so that, they give an example. But basically, the idea is now that your maze is split into 4 parts, and you have a different guy in each of the 4 parts, and, find the shortest number of steps now. So it turns out that there's not that many changes we need to make to do this for part 2. So one change is that now a grid, instead of having a starting position, has a list of starting positions. And so, now when we're parsing the raw string and we see this at, we append the starting position to the start. So now we have multiple starts, but we still have walls, keys, doors, work the same way. And it turns out that the one source shortest path, also that doesn't need to be changed at all. I don't think I changed it at all. And it, even when I have this guy, I still say starting here, I can get to A and that's it. And I don't have to go through any doors. Starting here, I can go to D, but I have to go through these 3 doors. Starting here and so on. So like that function still works the same and doesn't have to have any changes. Now the all source shortest path needs a slight change because now we basically have, instead of having, one starting point, um, where I just did results at, um, I'm going to call them results 0, 1, 2, 3 for each of those. So I just iterate over them and put results. It's fine to use string of a number because the keys are all letters. And so I do that, but otherwise it's the same. So now I have this all source shortest path. And so what's the shortest path from, you know, one, which is the second at guy, to whatever. So that works too. So that required a small change. And now I need to change the signature because before, if you remember, the signature said, where am I at and what keys have I seen before? Okay. But now I'm at kind of 4 places at once, right? So instead of a location, I have a list of locations. And so I just needed to change that into, you know, joining those as well. And so that's fine. And I don't need to sort them because they're in separate parts of the maze so that you can't get them in the wrong order. And so then for the shortest path, this is the same, this is the same, this is the same. Now for this priority queue, instead of starting at the at, so we started the at with no key seen yet. Here we have to maintain basically a list of 4 locations because we have 4 robots and they're different places. And so this list is going to say, here's where my 4 robots are at. Again, I'm going to pop this off, do the signature, check the signature, that's the same. And now the only thing that's really different here is that I have 4 robots, right? And so I have this extra outer loop. So before we would have said, find the one source shortest path and do this. Here, what I need to do is, one, I need to put a loop over the 4 robots, right? And within each robot loop, I do the same thing, except that, I need to make a copy of that list of where the robots are at and replace the ith element. So if I move robot 2 to E, I need to take that list that says where people are and change that to E. But otherwise, it's basically the same as well, and that works. So anyway, I didn't come up with this last night while I was working on it. I came up with part of this, but not really, but only about half of it this morning when I was drinking my coffee. I thought about it some during the day, and then this was the idea I had. I came home and tried it, and it worked. So I'm happy that it worked. I'm sad that it took me almost 24 hours from start to finish. I mean, I wasn't working on it for 24 hours, but still, it was 24 hours from when I started to when I finished. And anyway, I'm happy I got it working. It's kind of an involved problem, and like my first approaches to it were not wrong conceptually, but they were not efficient. And so making that mental leap from I don't actually want to do the searching, I just want to treat this as basically a kind of weird graph problem, from key to key with blockers rather than doing the search in real time, which was too slow. So, this is hard, and I think the stats probably reflect that. I mean, the latest day is always going to be like the lowest number, but like that's a pretty low number. Only 1,300 people finished it compared with, I mean, that's a third of the people who finished the day before, which is down a lot. So it was a hard problem, and I didn't look at the Reddit hints, so I'm happy I came up with them myself, but it took a while. Anyway, thanks for watching this, and maybe I'll do another one tonight.